Let's continue to know more and more about antiderivatives. What's this symbol? What's this notation about? The antiderivative is written in this notation. Here we go. Capital F of x is equal to the set of antiderivatives of f of x dx, or we can call it the integral. Here is the photo. This symbol is the integral of the peeled lemon is equal to the lemon before being peeled. So this lemon is the antiderivative of this, and this is the derivative of this. There are these kinds of integrals. Here is called the indefinite integral, and this is what we are interested in. And here is the definite integral that's usually bounded by numbers here. And you have to forget now about this one. All what we are interested in is this notation. And let's get started by the first example. How to find antiderivatives. Neglect this photo because it's just for fun. Antiderivatives are more easier than what you think. Let's take simple examples to make things easier. Here we go, the first one. F of x equals 3, small f of x, where small f of x is the derivative of this capital F of x. Now, how to determine this capital F of x that we call it, again, the antiderivative? Well, this capital F of x could be 3x, 3x plus 2, 3x minus 7, 3x plus radical 5, and more and more and more. Remember, I'm searching for a function whose derivative is 3. Then surely this function must be 3x or 3x plus any constant, because usually when I make the derivative, I just take the number multiplied by the constant, by the variable x. So because this function is constant and this is the derivative, then definitely the antiderivative should be either one of these. And there are more. So that's why we're going to write the following. Capital F of x, which represents the antiderivative, is equal to integral small f of x, which represents the derivative, dx. We write like this way, this notation. Now, I replace the given f of x, okay, which is 3, and I will get integral 3 dx, which is 3x plus c. The answer is 3x plus c because, again, I remind you, I'm searching for a function whose derivative is 3. Then definitely this function must be 3x. But 3x alone is not enough. I have to add plus c, because referring to these examples, you can notice why I should add plus c. Okay? Here is like a funny photo. That man is glad that he found the antiderivative. That man slapped him because he forgot to add c. So please don't forget to add c. Here is another example. Consider f of x equals, again, a constant minus 5. Then I have to find the antiderivative of small f of x, which is capital F of x. It could be, again, minus 5x alone, or minus 5x plus 0.5, or minus 5x minus 8, or minus 5x plus radical 3, and so on. There are so many possibilities. So again, I write it in this notation. Capital F of x equals integral small f of x, replacing by minus 5, I will get again and again minus 5x plus c, because I repeat, I'm searching for a function whose derivative is minus 5, then definitely it is minus 5x plus a certain constant. I'm giving you these examples because I want you to discover the rule. The first rule of antiderivatives is, who can tell me? Think a little bit. The first rule is integral of k dx equals kx plus c. So let's make a little comparison. Compare between this and this. Here you have integral minus 5 dx. Here you have integral k dx. Here you have the answer is minus 5x plus c. So as if you multiply this k constant here by x and you added a constant c. So the rule is, whenever you have the integral of a constant times dx into dx, then the answer of this integral is this constant multiplied by x, and you have to add always plus a constant c. Remark or a note, if we have integral of 0 dx, it is equal to the constant c alone. Why? Suppose that here it is k, and k here is 0. Then if I have to apply the rule here, I have to write 0x plus c, so it is just c, because 0x is 0. Let's continue. Here is like an activity. I want to find the antiderivative capital F of x of small f of x applying the rule. So this is the constant k, so I write the integral as follows. Integral of 1 minus radical 2 dx, and the answer is 1 minus radical 2x, so I just multiply this constant by x and add c. So it is very, very simple. You just multiply the constant by x and you add c. Now what to do with this c? What's this c? How can I get rid of it? Here is an example. Consider small f of x, which is the derivative, equals 3, where f of x is the derivative of this capital F of x, and there is an added condition now that f of 1 is minus 5. There is a new given. Okay? The difference between this example and the previous one, that there is a new given here that tells me that capital F of 1 is equal to minus 5. So how to benefit from this given? Here we go. First of all, I have to find the antiderivative, and I call it the unique antiderivative. And when I finish, I'll explain why did I call it the unique antiderivative. Why is it unique? Capital F of x, as I told you, integral f of x dx, I replace. So integral 3 dx, and the answer, as I told you, I multiply this constant by x and I add c. Now, I should benefit from this given to calculate c. So some calculations will lead me to c. F of 1 equals minus 5. Then all I have to do is to replace x by 1. So I take this value here, I replace x by 1. I will get 3 plus c is minus 5, thus c is minus 8. And thus the only antiderivative for this function with this condition is 3x minus 8, and there is no other antiderivative. And that's why I tell you here to find the unique antiderivative. Okay? Because this condition, okay, leads me to this c, and thus we have only one antiderivative for this function under this condition. And here is another example to make things more clear. Small f of x is minus 5, where f of x is the derivative of capital F of x, and f of 0 equals 2. So there is a given or a condition. Again, I write this, capital F of x integral minus 5 dx, and the answer is minus 5x plus c, and I have to benefit from this condition to get c. So f of 0 equals 2 means I have to replace x by 0. So minus 5 into 0 plus c equals 2, thus c equals 2, and thus the only antiderivative for this function under this condition is minus 5x plus 2. Hope you enjoyed antiderivatives, and I'll meet you later in more and more videos continuing this chapter. Thank you.